Hello everyone. In this video I'll cover the topic of arithmetic progression. I'll begin with an example. Consider this following sequence. If you observe carefully here, the difference between any two elements is 3. So to go from, let's say, third element to fourth element, we have to add 3. And similarly with all the rest of the elements, starting with this first element 1. So in general, if we have a first term, I'm going to call it A, and a constant difference between the consecutive terms as D, then this kind of sequence is called as arithmetic progression. So here in our example, we start with the term 1. So our A here is 1 and difference between the terms is 3. So to go from first element to second element, we add D in A. So the first element is A, second element will be A plus D, third element will be A plus D, adding D in this. So basically A plus 2D, A plus 3D, and so on and so forth. So you can generalize this and see clearly that the nth element of this sequence here, an, we will get it by adding n minus 1 times d in the first one, because through induction you can see this, because to go to second element we add d once, to go to third element we add d twice. So similarly, to go to nth element we add d n minus 1 times in the first element A. So this is our nth term of arithmetic progression. So I'll just write AP for that. So this is the nth term. So if we have been given a sequence, arithmetic progression, and we have to find nth term, then we can directly use this formula instead of going from the first element and adding D consecutively. So I'll take the previous example where our A was 1 and D was 3. So let's say I wanted to calculate the 21st element in this. So I want A21. So here A is 1, so 1 plus n is 21, so 21 minus 1, and D is 3. So this will give me 1 plus 20 into 3. So that will be 1 plus 60, and hence 60, I'll write it below, 1 plus 60, and this will be 61. There is one more formula of arithmetic progression that comes in handy when we want to add n terms of the sequence. So sum of first n terms is equal to n by 2, 2a plus n minus 1 times d. So this is the sum of first n terms of AP. This formula will be used many times to do calculations, and now we'll actually see how to derive it, starting with a general arithmetic progression of first term A and constant difference D. So let me do that now. How do we even get this formula in the first place? And then I'll take an example to show some of first n natural numbers. So let's write again our arithmetic progression. So we have A plus D, A plus 2D, so on and so forth, till, let's consider n elements, so A plus n minus 1 D. Now to calculate Sn, we add all these terms together. So Sn should be equal to A plus, I'll write brackets here so that to distinguish between the elements. So a plus d plus a plus 2d plus, in the end we have a plus n minus 1 d. So this is our Sn, adding first n terms of the arithmetic progression. Now I'll do a little bit of trick here and write this Sn in a reverse order. So I will just write this last element first and progressing in that fashion. This first element I'll write it in the end. So I'll write this Sn again as a plus n minus 1 d here. The second last element will be a plus n minus 2 times d. I add this all up till a, the last element. So I'm just writing this in reverse order. Okay. Now let me add these two equations, this Sn and this Sn, which are the same thing. So I get 2 times Sn on left hand side, and on the right hand side, if you see, if I add a and a plus n minus 1 times d, this gives 2a plus, okay, I'll make this more neat. Adding these two gives us 2a plus n minus 1 d, these two elements. Similarly, when we add second and second last element, this again gives us 2a plus n minus 1 d. And you can see that all these elements, if we add them in pairs, will give us this same sum, 2a plus n minus 1 times d. And we have n such terms because we are adding first n numbers. So there will be n such pairs of 2a plus n minus 1 d terms. So 2Sn will be n into 2a plus n minus 1 times d. Okay. So Sn will be n by 2, I am taking this 2 here, 2a plus n minus 1 d. So this is our formula that we get for sum of n terms of an arithmetic progression, and we can use this to add any arbitrary n number of terms. So let me take a nice example here. You must have seen that sum of n natural numbers as n into n plus 1 by 2, right? So let's get this from this formula. So natural numbers are basically, you start with 1 and you have 1, 2, 3, 4 and so on. So your A, this is again an arithmetic progression with first term as 1 and the difference as also 1. So Sn will be n by 2, 2 times a, so 2 into 1, plus n minus 1 times d, which is 1 again. So you get n by 2, here you get 2 plus n minus 1. So this will give you n by 2 and n plus 1. So sum of first n natural numbers is this. So let's find sum of first 50 numbers. So S50. So this is same as adding 1 plus 2 plus 3 plus 4 till 50. But this formula makes it easy to calculate. We don't actually have to sit and add all these terms one by one. So S50 will be 50 by 2 and into 50 plus 1. So basically 25 into 51. Let me quickly use my calculator to find this sum. So 51 into 25 is basically 1275. So this is the sum of first 50 natural numbers. that we have directly calculated from this formula. So for I'll take one more example. So let's find S10. So this was for natural numbers. So now let's find S10 for the previous example that we considered. So 1, 4, 7, 10. So here 10 by 2, n by 2, this is that term, and 2 times a, which is 1, plus n minus 1, so 10 minus 1 times d, which was 3. So this was 5 into 2 plus 9 into 3 will be 27. So this is just 5 into 29. Let me calculate that quickly. 29, that is 145. So if you add first 10 terms of this sequence, you get 145. So I'll just write this explicitly because this is just n is equal to 10. So this is just 1 plus 4 plus 7 plus 10 plus 13 plus 16 plus 19 plus 22 plus 25. I think I have got 5 terms, and one more, 28. So this is the sum that we are calculating. This is S10 for this arithmetic progression. So this I have calculated from the formula to be 145. And if you want to verify, you can actually manually add all these and you'll get the same answer. So this was all about arithmetic progression, and I'll write the formulas again for n terms. So AP is the sequences of the form A, comma A plus D, comma A plus 2D, so on and so forth. So nth term in this arithmetic progression is A plus n minus 1 times D. The sum of n numbers of this sequence is n by 2, 2a plus n minus 1 times d. So basically this is usually what you will have to know to do the problems of arithmetic progression. And you can solve a few more examples to practice this. Thank you for watching the video. I'll see you in the next video where I'll be explaining geometric progression.